400 million kilometers from home, imagine this scenario. You are on Mars. You have a sharp pain in your right side. Appendicitis. The ship's doctor confirms immediate surgery is needed, but there is a problem. Earth is 400 million kilometers away. Communication delays can be up to 24 minutes in each direction. Any medical emergency must be handled on site by the astronauts themselves. You cannot call a surgeon on Earth for real-time assistance because remote-controlled robotic surgery is not feasible. Any delay greater than 100 milliseconds causes noticeable problems that could compromise the surgical outcome. There is no hospital. There is no evacuation plan. There is no return home. A mission to Mars will last about 3 years, exposing astronauts to a hostile environment characterized by 38 G of Earth's gravity, a thin atmosphere, and a discontinuous magnetic field. The brutal reality is this. On Mars, either you solve the problem yourself, or you die. In Interstellar, Christopher Nolan showed us TARS, a sarcastic, reliable AI robot that saves the crew in critical moments. Honesty setting at 90%, Cooper joked. On Mars, we'll need a real TARS, and we're building it now. Why Mars? It's not just about exploration. Before talking about how AI will take us to Mars, let's ask ourselves, why go there? Dave Limp, CEO of Blue Origin, explains it clearly. The moon is our stepping stone. We need to build bases on the moon. We have water on the moon. We can build fuel on the moon, and that can be a stepping stone to Mars and the rest of the solar system. It's not just about planting flags or doing science. This allows us to build infrastructure in space that can move heavy industry off Earth, and we can enjoy the planet for what it is, Limp continues. The vision is ambitious but concrete. Moon operational base, fuel production from water, Mars' first permanent human colony, solar system expansion of humanity beyond a single planet, and it's not far-fetched science fiction. In the next 5 to 10 years, you'll see data centers in orbit, large structures connected by lasers powered by the sun, sending data back to Earth, predicts the CEO of Blue Origin. But to get there, we must first survive the journey, and that's where artificial intelligence comes in. Obstacle number 1. Cosmic radiation will kill us. The most insidious killer on Mars is invisible, cosmic radiation. Astronauts on a mission to Mars will be exposed for 3 years to galactic cosmic rays, GCR, high-energy protons, and high-charge, high-energy nuclei. On Earth, the magnetosphere and atmosphere protect us. On Mars, they don't. Exposure to GCRs increases about threefold when spacecraft venture out of Earth's orbit into deep space, where the protection of Earth's magnetosphere is lost. Some astronauts on past missions have even seen flashes of light with their eyes closed, radiation passing directly through their retinas. How AI will save us from radiation engineers are developing an arsenal of AI-driven countermeasures. Solar storm prediction. Machine learning algorithms analyze solar data to predict high-energy particle bursts, giving astronauts time to take shelter in the spacecraft's shielded areas. Trajectory optimization. AI systems calculate routes that minimize total exposure, balancing speed, fuel consumption, and launch windows, continuous biometric monitoring. Sensors built into astronauts' equipment collect data 24/7, while AI looks for anomalous patterns that could indicate radiation damage. Houston Methodist Hospital, in collaboration with NASA, is studying AI-enabled portable medical devices for consultation, technologies they hope will be ready in time for deployment on Mars. These digital doctors will be essential because due to the 8-minute delay in communications between Earth and Mars, real-time medical consultations would be nearly impossible. Obstacle number 2. No one will build your house before you arrive. The Apollo astronauts landed on an empty, hostile satellite. The first Martians won't. When the first humans set foot on Mars, they are unlikely to find themselves in a barren landscape. Any future colony will be prepared beforehand by robotic workers who will gather building materials, construct habitats, and perform dozens of other tasks necessary to prepare for human arrival. Why? Because sending building materials from Earth costs too much. 1 kilogram in Earth orbit costs about $1,000. On Mars, multiply that by 10. The solution is ISRU, in situ resource utilization. Use what's already on Mars: regolith, frozen water, CO2 atmosphere. The AI robots that will build Mars before us, The habitats will be delivered in 2 phases before the astronauts arrive. Semi-autonomous robots will select the site and dig a 5-meter deep crater, then inflatable modules will be placed in the crater to form the core of the settlement. The critical detail: given the vast distance from Earth and the resulting communication delays, deployment and construction are designed to take place with minimal human input, relying on rules and objectives rather than detailed instructions. Real projects in progress: AI Space Factory, Marcia winner of NASA's 3D printed habitat challenge. Marcia is a habitat built autonomously by robots using 3D printing with local Martian materials, with over 90% built using autonomous methods. During the NASA competition, robots built a shed-sized habitat in 30 hours without human intervention. NASA Armadas, a system that uses several types of caterpillar-like robots that can assemble, repair, and reconfigure structural materials for a variety of large-scale hardware systems in space. The robots can do their work in orbit, on the lunar surface, or on other planets, even before humans arrive. In recent tests, 3 robots worked autonomously as a team to build a metric-scale shelter structure using hundreds of building blocks. Published in Science Robotics, the system demonstrates that autonomous construction is not science fiction, it is engineering. NASA Valkyrie. A1. 88-meter-tall humanoid robot designed to precede humans on Mars missions to prepare habitats, assemble and maintain equipment, and perform experiments before human astronauts thus arrive. Valkyrie has hands sophisticated enough to use the same tools as humans, a huge advantage for versatility. Mars is a laboratory for more distant destinations. Every technology tested on Mars, from 3D printing with regolith to autonomous construction robots, will be the basis for colonizing more distant moons. Europa, Jupiter's moon, has oceans under the ice. Titan, Saturn's moon, has a dense atmosphere. But first we have to prove that we can build habitats autonomously 225 million kilometers from home. Mars is the testbed. Obstacle number 3. Life support must function for 3 years, without interruption. You can't call a plumber on Mars. If the water recycling system breaks down, you have a few days before dehydration sets in. If oxygen production fails, you have hours. NASA is developing life support systems that can regenerate or recycle consumables such as food, air, and water, testing them on the International Space Station. But there's a problem. The life support systems currently used on the ISS recycle less than 50% of resources. For Mars, the goal is to exceed 95%. Why 95%? Because astronauts on a round trip to Mars will travel approximately 140 million miles in deep space. The entire mission, including time in transit and on the Martian surface, will take about 2 years. You can't carry 2 years' worth of water. AI, as the invisible guardian of life at elect, we work daily with companies that generate enormous amounts of operational data, production, logistics, sales. Our job is to transform that data into actionable decisions automatically. On Mars, AI will have to do the same, but with one additional constraint: every wrong decision can be fatal. A Martian life support system will generate thousands of metrics per second: O2 and CO2 levels, atmospheric pressure, temperature and humidity, energy consumption, filter efficiency, pump and valve status. AI must monitor everything simultaneously, recognize abnormal patterns before they become critical, and intervene autonomously. AI-connected systems could manage tunnel stability monitoring, air quality, and even life support. This would be crucial for Martian habitat since colonists will not have terrestrial repair facilities available. These systems are not designed just for Mars. A mission to Jupiter's moons would take 6+ years. To Saturn, over 10 years. Every lesson learned on Mars, every optimized algorithm, every perfected recycling cycle will become the DNA of vital systems for deeper missions into the solar system. SpaceX Plus. NASA. The race to 2030. The good news? We're not starting from scratch. NASA is advancing many technologies to send astronauts to Mars as early as the 2030s. The strategy is to test everything on the moon first, Artemis program, then apply the lessons learned to Mars. The critical factor: nuclear propulsion. To reach Mars as quickly and safely as possible, nuclear-enabled propulsion is needed to reduce travel time. NASA is advancing multiple options, including nuclear electric and thermal propulsion. Why is this so important? Less time in transit means less exposure to radiation, less muscle and bone loss, less psychological stress, fewer consumables needed. SpaceX Starship, the taxi to Mars. SpaceX has completed 49 milestones in the development of the Starship Human Landing System, HLS subsystems, using advanced AI systems for quality control, predictive maintenance, and flight data analysis. The impressive detail: the 120-meter Starship, the most powerful rocket ever built, is driven entirely by onboard software without a human pilot, demonstrating advanced AI control of launch and landing operations. SpaceX is self-funding over 90% of the costs, building high-speed manufacturing capabilities in Texas, Florida, and California. The goal: to make travel to Mars not only possible, but repeatable and accessible. Simon, you won't be alone. The psychological factor. Let's talk about the most underestimated threat: isolation. A mission to Mars will push human psychology to limits never before tested. Life in a confined capsule for years means isolation, monotony, and complete dependence on the same small crew. Astronauts on the ISS can talk to their families in real time. On Mars, every conversation will have a 20 to 40-minute delay. Astronauts will face a psychological adjustment similar to that of military personnel after overseas deployments. During missions, they will miss significant life events: birthdays, weddings, births, funerals. Simon, the real TARS remember TARS from Interstellar? The spherical robot that floats around the spaceship, helping the crew and joking with them? It's no longer science fiction. Simon Crew Interactive Mobile Companion is a spherical AI robot developed by Airbus and IBM that assists astronauts on the International Space Station. But Simon 2 goes beyond technical assistance. It includes Watson Tone Analyzer, which assesses astronauts' emotions through linguistic analysis of their tone of conversation, transforming it from a scientific assistant into an empathetic companion. Why is this crucial for Mars? On missions to Mars or beyond, it could take 30 minutes just to receive an answer to a simple question from Earth. A trained Simon could communicate quickly and reliably even in deep space far from Earth. Perseverance. AI is already working on Mars. This is not just theory. AI is already exploring Mars right now. 88% of the driving done by the Perseverance rover has been autonomous. The rover captures images of the terrain with its cameras, analyzes these images with an onboard computer to identify hazards, then navigates around obstacles, driving over terrain that no human has ever seen. Perseverance can wait 22 minutes for instructions from Earth. Humans cannot. PyXL, planetary instrument for X-ray lithochemistry. The first instrument on Mars to use AI to make autonomous decisions based on real-time analysis of rock composition. It uses adaptive sampling. The software autonomously positions the instrument near a rock target, then analyzes pixel scans to find minerals that warrant further examination, all in real time, without talking to Earth. Aegis, autonomous exploration for gathering increased science. An AI system designed to autonomously collect scientific data during planetary exploration. Aegis, used by the Curiosity rover, paved the way by allowing the rover to fire its ChemCam laser at interesting rocks without waiting for commands. The lesson is clear. AI on Mars is not an experiment. It is operational, proven, essential. Beyond Mars, the space infrastructure of the future Mars is not the endpoint. It is just the next step. As Dave Limp of Blue Origin explains, once we build bases on the moon with water and fuel production, it becomes a stepping stone to Mars and the rest of the solar system. The long-term vision is revolutionary, moving heavy industry into space. AI as the foundation of the space economy. Every element of this vision requires AI: orbital manufacturing, AI robots assembling structures in microgravity, asteroid mining, autonomous resource identification, extraction, refining solar stations, optimal positioning, solar tracking, Earth space energy grid management, space traffic, thousands of satellite stations, spacecraft, AI coordination is needed to avoid collisions. This allows us to build infrastructure in space that can move heavy industry off Earth, and we can enjoy the planet for what it is, concludes Limp. Conclusion: AI is not optional. Let's return to our initial scenario. You are on Mars, you have appendicitis. You cannot call home, but you have a medical AI system that diagnoses and guides the team surgeon through the procedure, habitats built by AI robots before your arrival, life support monitored 24/7 by algorithms that predict failures before they happen, Simon to keep you company, monitor your psychological state, and answer your questions. Real-time data from Perseverance and other rovers mapping resources. Mars is 400 million kilometers away. There is no help. There is no evacuation plan. There is no second chance. The only way to get there alive is with AI working 24/7 to keep us alive. NASA 2040 AI Track, launched in 2024, is an initiative focused on advancing AI in space exploration to improve autonomous decision-making, spacecraft navigation, and scientific discovery. This is not a long-term project. It is the roadmap for the next 15 years. Robots will build the bases. AI will protect us from radiation. Algorithms will manage every molecule of air and water. Digital companions will preserve our sanity. Humans will explore, they will discover, they will survive. And in 10 years, when the first astronauts set foot on the red planet, something much bigger than a single mission will begin. Mars will be the first colony, the first supply hub, the first shipyard to build the ships that will take us to the moons of Jupiter, the rings of Saturn, and beyond. Artificial intelligence is taking us to Mars, but Mars will take us to the stars. TARS was science fiction. Simon is here. Perseverance is working on Mars right now. And in 10 years, when we fire up our engines on the surface of the red planet to head for our next destination, it will be because AI has made us a multi-planetary species. The journey has only just begun. Fabio Lauria, CEO and founder, Electis RLPS. If you are interested in learning more about how AI is transforming not only space, but also business on Earth, keep following this newsletter. Welcome to Electis newsletter. English. This newsletter explores the fascinating world of how companies are using AI to change the way they work. It shares interesting stories and discoveries about artificial intelligence in business, like how companies are using AI to make smarter decisions, what new AI tools are emerging, and how these changes affect our everyday lives. You don't need to be a tech expert to enjoy it. It's written for anyone curious about how AI is shaping the future of business and work. Whether you're interested in learning about the latest AI breakthroughs, understanding how companies are becoming more innovative, or just want to stay informed about tech trends, this newsletter breaks it all down in an engaging, easy to understand way. It's like having a friendly guide who keeps you in the loop about the most interesting developments in business technology without getting too technical or complicated. Subscribe to get full access to the newsletter and publication archives.